Hello friends, welcome to Simulation Card, the world's first platform for buying and selling the simulation models. It's a marketplace. Anyone with a simulation can sell their models, and the people who are in need of simulations can buy models from here. Okay, so today we are going to see the simulation of this one, active cell balancing system for lithium-ion batteries. Okay, so if you want to purchase this, you can uh, add this to the cart and you can purchase it. Okay, so let us get into the model. So this is a simulation which we are going to simulate. So the reference for this is this paper. So capacitor based active cell balancing for electric vehicle battery systems. So here they are mentioning few techniques like passive cell balancing, also active cell balancing. In active cell balancing we have few types like switched capacitor balancing, then double tiered switch capacitor balancing. In this particular paper, they have invented a new switching topology. Uh, so that topology has one more capacitor connected in parallel with a double tiered switching capacitor balancing technique. Okay, so the model which I have simulated is this one. Okay, so this is the one which I have simulated. Double tiered switch capacitor with additional capacitor. Okay, so what we are trying to do here is there will be n number of capacitors, I mean, there will be n number of lithium-ion batteries, and all the batteries will have different SOCs. As you can see here, all the batteries will have different SOCs. So each battery will have different state of charge. So in this case, there's a high chance for the battery to get damaged because of this difference in cell voltages. Okay, because of the difference in charges present in each and every cell. So what's our objective here is we are trying to make all the batteries to have same value of SOC. Okay, so as you can see here, a battery is having 98% SOC, and the lowest SOC can be seen in the seventh battery. I mean, and some other battery here. So our objective is making the uh, SOCs of different batteries to converge to a same point. Okay. So initially the SOC of this battery is 98 percentage and the lowest one is around 94 percentage. So after some time, the SOCs, batteries with higher SOC will decrease and the batteries with lower SOC will get charged. Okay, this will get discharged and the batteries with lower SOC will get charged, right? So this is compared for different topologies. So this one is for switched capacitor and this one is for double switched capacitor, and this one is for the one which I have simulated here. Okay, so let us get into this simulation. So here we have different batteries. So different batteries will have different SOCs. Okay, and here we have the contactors and here we have the capacitors connected. So here we have one additional capacitor connected across the all other capacitors, and here we have the switching pattern or switching logic. So through this switching logic, all the switches will be switched. Okay, and it is simulated for a duration of 2000 seconds. So since it will take a long time to get simulated, I have simulated it already. So as you can see, the battery with higher SOC is getting discharged and the battery with lower SOC is getting charged. Okay. So all the batteries are moving towards, are converging, SOCs of different batteries are converging to a point. Okay. So if this happens for over a period of time, the battery will get calm and all the SOCs of the batteries will come and converge at the point. Okay, so this will increase the life of the battery. So thanks for watching. If you want this video with this particular model, you please uh, click on the link given in the description, and that will direct you to the website, and there you can purchase this model. Thanks for watching. Please share this to your friends, and please do like your channel. Thank you.